Welcome to M Cubed. We're going to be talking about the correlation coefficient today, which is represented by the letter R. So R is a unit of measure that is called the correlation coefficient. And the only way to calculate this correlation coefficient is to run a test called linear regression or exponential regression or quadratic, so any type of regression, which you can check out my other video about how to do this on a TI-84. Now, the correlation coefficient is going to be a number that exists between -1 and +1. So when we have a negative correlation, that means that you have a decreasing relationship. If you have a positive correlation coefficient, that means that you have a positive relationship. So if we were running a test of linear regression, if we had something that was negative, our regression would be in a negative slope. If we were doing exponential, it would be a decreasing function. Same thing with positive. If it was positive, it would be an increasing for linear regression, and for exponential, it would also be increasing. So what is the purpose of this correlation coefficient? Well, the range of numbers from -1 to +1 tells you how strong the relationship is between the two sets of data that you're running the test for. So the closer you are to a -1 or a +1, the stronger the relation is between the two variables. So this would actually be a perfect positive correlation, and this would be known as a perfect negative correlation. Now, the closer you get to 0, that is indicating that you have no correlation whatsoever, or the correlation that you have is very, very weak, which means that statistically you wouldn't want to base any information off of it because it's not going to be a strong enough relationship. So this means no correlation. So then you have to consider what happens if you have a number that exists somewhere closer to 0 in the positive or closer to 0 in the negative. These would be considered weak correlations. So you wouldn't want to trust them again, but it would be good to know that you don't have no correlation, like there might be something there. Maybe you need to look at a bigger set of data, but for the data that you've entered in to run the regression test, you don't have a relationship. So the closer you get to -1 or +1, that means that you have some sort of strong relationship. It's not perfect because you don't have an exact -1 or +1, but it is strong. So this would be strong positive, and then this would be strong negative. You would want to use this correlation coefficient when you're running your regression test to determine what type of regression fits the information that you've inputted. Maybe you are thinking that it is going to be linear, but when you go to run the test, you maybe get an R value of, let's say, -0.5. So then you say, well, I'm going to run the exponential regression and see what that's going to hold. And when you run that one, you get an R value of -0.8. But then let's say that you run a regression for quadratics, and when you run the quadratic, oh, I guess this would be negative. Let's go back. For negative, you would see that you have an R value of -0.99. So out of the 3 of these R values, you would then determine that the quadratic regression is the data that best, is the regression that best fits your data. So the relationship between the two variables would have to be quadratic. And this would also be true over here, but let's say it's the reverse. Let's say that we run the exponential regression and we get R is equal to positive 0.7. And then when we run it for the linear, we get R is equal to positive 0.98. Again, you would then choose the linear regression equation that represents your data, and that would be the line of best fit that you would want to use. I hope this explains linear regression, the correlation coefficient. And if you want to stop back to see more about linear regression, exponential regression, or quadratic regression, check out our next video.